Guys, welcome to episode 13 of TFL Talking Trucks. I'm Andrei Smirnov with the Fast Lane Truck. With me is my co-host.
It's Roman, and today, Andre, we've got a very special guest because we're going to be talking about crashing trucks, which is one of my favorite topics.
Yes, and with us is Russ from IIHS. Russ, can you please quickly introduce yourself?
Yeah, hi everybody. I'm Russ Rader. I'm Senior Vice President for Communications at the Insurance Institute for Highway Safety. We're a nonprofit research group funded by automobile insurance companies in North America.
You know, Russ, I got to say, a long time ago, I went to graduate school for broadcast journalism. This was a very long time ago, and I happened to go to Washington, D.C., and I actually went to your facility back in the day. This was, like I say, 1997. And saw what you guys were up to, and I've been a big fan of, what you guys do. I think it gives people a pretty independent way of looking at the safety of vehicles. So it's pretty impressive that you can take, vast amounts of vehicles and actually crash test them, get them off the lot, and then go out and, show to people and show to the manufacturers, perhaps more importantly, what they're doing right and what they're doing wrong. And I think because of that work that you guys have done, cars and trucks have become so much safer because people now look to you guys when they're making their car and truck buying decisions.
Thank you for joining TFL Talking Trucks podcast. If you love pickup trucks or big full-size SUVs, if you love trailering, towing, and going off-road, this is the right place to be. Together, we can make this podcast the most popular ever.
Yeah, and the Institute started doing crash tests as an independent third-party entity because, for that very reason, we saw a way to push for improvements in automobile safety and crash test safety beyond what was being required by government regulations.
Yeah, it's funny because back in the day, and this is like even earlier, before my time, people used to get impaled on their steering wheels, right? When a vehicle crashed, the steering wheel would actually, collapse, and you would get impaled on the steering wheel. This is before, and so it's great that there's somebody out there, who's taking it beyond what the government does. Tell me about IIHS, how it got started, and kind of what your mandate is, and the process that you use to attain these vehicles.
Well, the Insurance Institute for Highway Safety was started actually in 1959 by a group of insurance associations, and it started out as an organization that offered grants to states and other organizations to do traffic safety work. And then the terrain really shifted in the 1960s when books like Unsafe at Any Speed by Ralph Nader came out, and there was this an effort by the Lyndon Johnson administration to really prioritize auto safety. And it became more of a scientific endeavor, and the Institute was changed in the late 1960s into the scientific organization that it is now. We didn't start crash testing vehicles until the early 1990s, and we do a lot of other kinds of highway safety work besides crash testing. But the crash tests really became our signature. They started in 1995 with our first set of tests, and we launched the tests, and the way the tests are done now, even though we have many more of them than we once did, pretty much work the same. We choose vehicles or vehicle groups that we want to test, and we go out to vehicle dealers and we buy all of the vehicles that we test, just like a consumer would.
And you're funded by the different insurance companies that make up the consortium?
Yeah, we're funded entirely by automobile insurance companies, and they fund us because highway safety is important. They want vehicles to be safer. They want the roads to be safer, and it's really the kind of the joining of the interests of the public health community in saving lives and preventing injuries, and the interests of a big industry, the insurance industry, which wants to reduce the amount of payouts that they have to make for repairing vehicles and people after crashes.
So, obviously in this podcast / video, we're going to be talking about trucks and the trucks that you've crash tested, and you've done mid-size trucks and full-size trucks. And at the end, I want to talk about kind of how you've raised the level for manufacturers in terms of not just crash test standards, but also headlight standards, everything that goes into safety. So Andre, take it from here. What trucks do you want to know about, and which ones do you want to know how they've done and how they were crashed?
Well, I want to start with the mid-size trucks really quick, and then go to the most popular vehicle of them all, right, which is the Ford F-150.
Sure.
And Russ, obviously, I mean, you guys over the years have extended your testing to these vehicles, and it's really important conversation because pickup trucks are becoming more popular. They're becoming family vehicles, right? Not just for work. Now most of them have 4 doors, crew cabs, 4-wheel drive, and luxury features of every kind. So I'm really, I like that you guys are doing this and you're extending this specifically to even the half-ton trucks like the F-150s. I just wanted to go over, let's talk a little bit about the mid-size segment. For example, the Toyota Tacoma, which leads it, right? Leads it in sales.
Yeah.
Can you just go over the number of different tests you do, like the small overlap and roof strength and those types of things?
Well, when we first started doing crash testing, we were doing one crash test. It was called the moderate overlap frontal crash test, which we developed because it was we saw in the real world that people weren't always injured and killed in a crash where the whole front of the vehicle collides with something else, right? The whole front of the vehicle is involved. Vehicles don't just crash into walls with the whole front of the vehicle involved. And so we started doing that moderate overlap test where only a portion of the front end of the vehicle is involved in hitting the barrier. And now we do a total of 6 different safety tests. We do the moderate overlap frontal test. We do a side impact test. We do the roof strength test, which measures how well the vehicle would hold up in a rollover. We do 2 other kinds of more severe frontal tests, which are those small overlap tests where even a smaller part of the front end is involved in the crash. And we also simulate a rear impact so we can measure how well your seats and head restraints would protect you in a rear impact where your head and your torso want to move backwards in the crash, and that leads to what's known as whiplash. And so we've developed those tests and added them over time as we've seen how people are hurt and killed in real crashes. That roof strength test that you mentioned is one that is a test that we developed after we saw that people aren't just killed in rollover crashes because they're ejected, right? That's sort of a common thing that you see when people talk about rollovers. It's the same principle in the rollover crash is the principle we apply across all of our crash tests, which is it's packaging 101. You want the package where the people are sitting to stay in one piece and not crush. And if it does that, if it stays together, then a properly restrained, belted occupant has a better chance of surviving. And so a stronger roof means that the roof is likely to crush less, and that gives room for the people to survive the rollover.
So do you have any numbers in front of you? How is the Toyota Tacoma done specifically?
Yeah, the Tacoma is a top performer among this sort of mid-sized pickup group. It earns a good rating in that small overlap driver's side test. We also flip the test over to the other side, and it earns an acceptable rating in the passenger side test. So if you look at our ratings, they're not a star rating system like the government uses. We rate the vehicles good, acceptable, marginal, or poor. And across the board, the Tacoma earns good or acceptable, that one acceptable rating in the small overlap passenger side test. And we're going to talk about headlights later as well. And there is one headlight type on the Tacoma that gets a good rating there.
So what's the difference between acceptable and good? How do you go from being acceptable to being good? What has to happen?
Well, we usually say somewhat facetiously that good is good and acceptable is acceptable. So what we're doing is really measuring two different things. We're looking at how well the occupant compartment holds up, that packaging 101. We're measuring the areas of the occupant compartment that may crush or push back toward the occupants. So that's one area of our ratings. And then we're also looking at the forces on the driver dummy or the passenger dummy if we're measuring the passenger side protection. And we're looking at what the likelihood would be for head injuries or chest injuries or leg injuries. So when a vehicle gets a good rating, that means that the likelihood of a very serious injury is quite low. If it's rated acceptable, that means there's a little bit more elevated risk of injury. And I can look at the Tacoma right now and give you an example of that. So when we look, for example, at the acceptable rating for the passenger side test, looking across all of those different ratings categories, what brought down the Tacoma's rating from good to acceptable was that we had an elevated risk of lower leg or foot injury. And so that's something that we don't want to see in a test like this. I'm looking at the intrusion measures, and what happened with the Tacoma was there was, although the intrusion overall into the passenger space was low, there was some unusual intrusion pattern of the footwell, which contributed to the likely risk of injury to the lower leg or foot. And that is one of the categories that we rate because that is an area where people in real world crashes often get hurt. So that's what brought the Tacoma's overall rating in that passenger side test down one rung to acceptable.
Now, Andre, you know this better than me, but I think there are 5 midsize trucks. I'm going to try to go down the list in base of popularity. So the Tacoma tends to be the most popular, followed by the GM twins, the Colorado Canyon, followed by, I think, the Ranger, followed by the Frontier, followed by the Ridgeline. Am I missing anything, Andre?
Yeah, well, the Gladiator, and here in front of me, I actually have a story that we did on TFL Truck using the data from IIHS. And by the way, Russ, you mentioned some data right now. People can find it immediately on your website, right?
That's right. You can look at the individual areas where we rate the vehicle, how the vehicle did. We also put the nitty-gritty details on the website too, if you want to see the actual measurements.
And it's iihs.org. So
That's right.
I think it's really well laid out. I'm not just saying it because you're here, Russ. I'm saying it because you can look it up by vehicle or by actual class of vehicle, which is I think is really good. And Roman, to your question is, we recently did in 2019, we did a story based on the IIHS data, and there were top 5 midsize trucks because the Gladiator hasn't been tested yet. So the Gladiator is a brand new truck that's just entering the market over the last few months. And obviously it takes time to go through all of the testing procedures. And what I'm seeing is on this, we kind of rank them, right? What I'm seeing is kind of the older design vehicles. So for example, the Nissan Frontier that's been around as a design since about 2005 year approximately, had some poor ratings as well. And I mean, just in certain categories, not overall. But as soon as the vehicle gets redesigned, what I'm noticing is its rating jumps up because I think the manufacturers obviously are watching this space very carefully. They want to build the safest vehicles possible. And actually the safest midsize truck, Roman, you might be surprised or maybe you're not surprised. What's the safest midsize truck?
Can I guess?
Yeah,
I'm going to say Ridgeline.
you're absolutely right.
Yeah, I figured. Yeah, it's the most car-like in a lot of ways. And to me, Russ, I don't know if you've noticed this, but to me, it seems like manufacturers have given more, I'm going to be political here, priority to redesigning cars than redesigning trucks. Because cars for a long time were kind of what more people bought. But now that it's slowly starting to go from cars to crossovers to trucks, maybe that prioritization will happen to trucks as well, and not just to cars. Are you seeing that at all? How do you decide
Yeah.
vehicles to test?
Yeah, we are seeing that, and I think in the past it certainly was true that for pickup trucks there was a longer design cycle. Platforms lasted longer between redesigns, and so we didn't see in the past improvements as fast as we saw with cars, or certainly with family-oriented SUVs, and I think that may certainly change as sedans become less popular and light trucks take over a majority of vehicle sales, and we try to focus on the heart of the market in each one of these vehicle categories. We're not able to test everything, so we try to test the most popular light trucks on the market. And we are ourselves shifting as the market changes, and are focusing more on the SUV and pickup area than we probably were 15 years ago.
So I've got two questions for you before we get into the full-size trucks, and this is something that I've always wondered about. So one's kind of, I think, a question a lot of people have, and the other one is something that's a modern trend. So let's start with the question a lot of people have. If you have two vehicles that crash into each other, right, and you're not crashing two vehicles into each other, obviously you're crashing into stationary barriers, but to what extent does physics have a lot to do with the safety of those vehicles? More specifically, I mean, let's say you take a Ford F-250 and we just bought a smart car, right? And you crash the two together. The physics of that crash are going to be so interesting, because you're going to have this vehicle that weighs, 7,000 pounds versus this vehicle that weighs 2,000 pounds. How important, what role does that play in the safety of passenger and driver occupancy?
Yeah, it plays a very important role. It's a good question, because people ask us that question, and we try to do periodically demonstrations to show that there is the disparity between how a small car, for example, performs in a laboratory crash test, and how what the outcome, or how different the outcome might be in a crash with something much bigger and heavier. And it doesn't even have to be much bigger or heavier. We have done some tests. You mentioned the smart car, where we did that head-on crash, pairing the smallest vehicle from a manufacturer. At that time it was Daimler, and we used the smart car, and the sort of a small car from the same manufacturer. In this case, it was a Mercedes C-Class, and we crashed them together, and you see the same thing, that while the smart car does very well in our frontal crash tests, it didn't do very well in the test against the Mercedes C-Class, and that is just physics. So there are sort of two collisions that happen when two vehicles collide. There's the actual collision of the vehicles, and then because of physics, the heavier vehicle tends to drive the smaller vehicle backwards after the initial impact, and that causes a second collision, and that is what is happening to the human body as it is first decelerating in the initial impact and then accelerating backwards in the subsequent event as the crash unfolds, and that is something that human bodies are not built for. So it's worse for the people in the small car than it is for the people in the bigger, heavier car.
Yeah, I know, because in the smart car came out, Mercedes at that time, who owned smart car, of course, said that it's got a lot of airbags. I think they said it's got a trinium or something, some kind of a body structure that's much more rigid, right? Because manufacturers can use different types of metals to reinforce different parts of the vehicle. But that you can make a very rigid cage, but it's like your brain inside of your skull. The skull is very rigid, but that doesn't mean that your brain is going to survive that impact, right? Because it's still going to hit against something, and the physics of that crash are going to cause other injuries that aren't intrusion, but they're just deceleration, acceleration injuries.
Right. Yeah, that's right. And we don't tell people, don't buy very small cars. Because people have a lot of reasons besides safety that they want to drive a small car. Maybe they live in a dense urban, city environment, and a small car just fits their needs. So what we tell people is you should buy the car that fits your needs. Just recognize that there is this disparity, and make sure that you're buying a small car that affords the best protection that you can.
The other question that I want to ask you about is something that's very modern and very trending right now. And places like Texas, right? 1 out of 4 vehicles sold are trucks. And then here in Colorado, it's very regional, right? You go to DC and you still see a lot of sedans, you'll see a lot of crossovers. I was just in Moab this weekend. I didn't see any cars. I mean, it was all trucks and crossovers, side by sides. So let's keep that in mind. But the biggest truck trend right now, I think, is people lifting them, right? So they take these trucks and they lift them. And I've always been curious what happens when you have a lifted truck. And let's say it's not even a big lift, it's a 2 or 3 inch lift, right? And then you pair that up against a sedan or even a regular size crossover. All of a sudden, instead of the vehicles hitting like this, right, they're hitting like this. And, this being the sedan and this being the truck. Have you guys given any thought to actually doing a test to see what happens when you have a tall vehicle that hits, a standard height vehicle?
Well, we've done a lot of work on this back in starting, I guess it would be the early 2000s. The federal government asked us to lead a kind of a working group with the automakers to work on this issue of what's known as incompatibility. And even if a light truck has not been lifted or modified, you can get that disparity where the energy absorbing structures of the light truck ride over the energy absorbing structures of the car. And so we worked with the automakers to address that. One of the things was that side airbags became standard in cars to help protect against those impacts from taller riding vehicles. And then truck manufacturers actually added structures or lowered the structures in the front ends of SUVs and pickup trucks to better align those energy absorbing structures. But you're right, when you modify the truck and you lift it up, you're basically, you're overcoming, you're changing those structural dynamics that are designed to protect people in cars. And you're probably also raising the center of gravity in your own vehicle, where you might make it more likely to roll over, for example, in a crash.
Which is not a good
thing. I've seen Russ where you've done some work with semi trucks even and trailers, right? So it's semi truck trailers. They're all over the highway, right? They're everywhere because they're integral to the economy and moving stuff. And then a lot of the trailers now have those little bumpers that hang below the tractor trailer, right? And you've done a lot of work with those.
Yeah, that's a type of crash where a vehicle, a passenger vehicle like a car or even an SUV or a pickup truck, strikes the back of a semi-tractor trailer. And those bumpers or guards that hang down behind trailers are there for a specific reason, and that is to prevent what is called an underride crash, where the passenger vehicle actually rides underneath the trailer. And it's one of those terrible crashes where the energy absorbing structures of the vehicle aren't even involved in the actual crash. The passenger vehicle goes under the trailer, and then it's really the windshield and the top structure of the car, SUV, or pickup truck that's actually the thing that is hitting the trailer. It's a devastating kind of crash for people in the passenger vehicles, and those underride guards have been getting stronger to prevent that underride from happening. So if the underride is prevented, then the energy absorbing structures that are built into vehicles because of crash tests can do their work and prevent people from being hurt in those crashes.
All right. So Andre, now that we've talked about lifted trucks and semi trucks, let's talk about full size trucks. You want to delve into that topic?
Yeah, absolutely. I mean, these are the most popular vehicles in many ways. We talked about, regional sales, Texas, Colorado, pickup trucks are huge. And what I'm noticing, and Russ, I'm looking at, once again, the latest data that I have from you, and this is basically 2019 and some 2020 models with like headlights updates, because that's also becoming more and more important. And what I'm seeing here in the full-size market, the half-ton trucks specifically, like the Tundra, the Titan, the Silverado, the Sierra, the Ram 1500, the F-150 from Ford, they're a lot closer in their ratings. So this market seems to be very competitive. Yeah. Am I correct by looking at this?
So I guess the question, what's the safest and what's the least safe full-size truck, according to you guys?
Well, one of the things that we try to do is, rather than saying a vehicle is the safest or the least safe, we do the tests and we present the ratings for consumers to, make the best choices about which vehicles perform the best in safety tests. And I think what you'll see as you look at our ratings for full-size pickups, as Andre said, there are some popular models grouped up toward the top, with a lot of green goods across the rows of tests. But there are also some vehicles that aren't doing so well. And if you go down toward the bottom of the list, the Toyota Tundra Crew Cab is performing the worst among this group that we've tested, earning only a marginal rating in the small overlap front test and a poor rating in the driver's side small overlap test, poor in the passenger side small overlap test. Mm-hmm. And I think one thing to point out with pickups, particularly this full size group, is that we have been raising the bar on safety gradually over time. And one of the things we added for our top safety pick criteria for 2020 is that a vehicle has to have an effective front crash prevention system that can prevent collisions with pedestrians. So we're not only prioritizing systems that can prevent crashes with other vehicles, but also those that can avoid pedestrian impacts. And sometimes technology is slower to advance in the pickup group. And so we have some vehicles where that type of system is not available on the pickup, or it may have become available and we just haven't tested it yet. So that's one area where pickups may lag behind. And also, as you mentioned, in the headlight area, pickups have been lagging behind other vehicle categories.
So the Tundra, like you said before, is one of the oldest trucks in that category, just like the Nissan Frontier, and that probably has a lot to do with why it's performing not as well as some of the other vehicles, just because the design is getting pretty long in the tooth. Which of the full-size trucks are doing good? Which ones are the ones at the top of the list?
Well, we don't have any top safety picks in the full-size group, as we've made the criteria harder. Pickups just don't make the cut, partly because of that pedestrian prevention system that I mentioned, and also for our top rating of top safety pick plus, the vehicle also has to have good rated headlights that come standard equipment on the vehicle. So having said that, among the full-size pickups that we have tested and rated, the Ram 1500 is at the top of the list. The Ford F-150 also performs well in crash tests, getting good ratings all across the board. The Honda Ridgeline that you mentioned earlier does very well in crash tests. And I guess the thing that is important for people to remember is it's not just about crash test ratings anymore. Vehicles could get through all of our crash tests and do well, but that was a number of years ago, before we started to see more and more of this technology on vehicles that can prevent crashes from happening altogether. And so front crash prevention, the automatic braking systems are very important in our ratings programs. And again, many of these top rated pickups have a vehicle-to-vehicle front crash prevention system available as an option. But if you're looking for a state-of-the-art vehicle on a pickup truck, that automatic emergency braking is still very much typically optional rather than standard. And that's really not the case with many SUVs and cars today. Typically, that automatic emergency braking system is increasingly standard on the new vehicles.
Yeah, it's interesting because you look at especially the Japanese manufacturers. Like Toyota has their suite of safety features that they've now made standard on all of their cars, and yet it's taken them a little bit longer to move that into their trucks. And I just don't understand why there's that disparity between, well, each of our cars gets the safety suite, but the trucks don't get them. And Honda's doing the same thing, and so are the Korean manufacturers. But yeah, you'd wonder why not just put them into maybe because the Tundra is now getting to be so old that there needs to be a redesign before they can actually retrofit it with a lot of those safety systems.
And they have to some extent because, right, I mean, I was surprised when the 4Runner and the Sequoia and the Tundra got adaptive cruise control, right? I mean, it's pretty, obviously they're trying to work on this, but maybe they're prevented by, and we don't know this for sure, maybe by the inherent architecture of the vehicle, right? All the wiring that has to happen and all of the sensors.
Yeah, we have to ask them. I think we're speculating now.
Right.
I think the Tundra, too, it's important to point out, even though it's an older vehicle, it has the standard Toyota front crash prevention systems. It's the only large pickup that has that system standard. I'm just looking to make sure that's true.
And now the Titan for 2020 has included that as well. So, if we look at GM and Ram and Ford, I think they're getting there. But I wanted to make one point about pickup trucks is that if you look at a crossover, there's maybe 5 trim levels and maybe 1 or 2 engine options, right? If you look at the pickup truck, there's a 2-door version, extended cab version, crew cab version. There's 3 different lengths, and then there's 7 different engines. Right?
Yeah.
So the variance of a pickup truck and what you can get in a very basic pickup truck often case is not the same as what you can get in a very luxurious one. So it's just the range of availability and options is so huge.
So Russ, I was looking at your headlight testing. It's pretty cool the way you guys do it. I mean, you seem to set up a course and then you have the vehicle drive down the course. And then you kind of see how the headlights illuminate. Tell me about how you decided to add headlights, because that has thrown a lot of, you reset the bar again with headlights. And so to get a top safety pick, you have to have good headlights now. And that's something that the manufacturers are working, I hope, to meet. Tell me about the test and how you chose to do that.
Well, we started looking at different headlight technologies, when I was growing up, you had the sealed beam headlights that you could go buy at the auto parts store and replace the headlights on your car. And the headlight for one GM car would fit in another GM car. But headlights are, of course, very different today. They have some advanced technologies available on them. And so we started looking at these different technologies in headlights and whether they improved visibility. And we began to recognize that even separate from that technology, there's a wide range of performance in not only how far headlights shine down the road, but also how much glare they produce for oncoming drivers. And so we started to look at this more carefully because the federal standard for headlights doesn't test the headlights on the vehicle. It's a laboratory test that tests illumination with the headlights sitting in a lab, and they don't measure performance out on the road. And so we introduced the headlight test to try to drive improvements in headlight performance like we've driven improvements in crash test performance. And we did it in part because headlights are an important safety feature, right? I mean, if you're doing a lot of driving at night, you need to be able to see at night. And a headlight that is a good performer can, in our tests, allow you to see almost twice as far down the right side of the road on a straightaway than you could with a poor rated set of lights. And so that's why we launched the headlight tests in 2016.
Yeah, I don't think any of the pickups yet meet the highest level for headlights under your testing, unless I'm mistaken, Andre. Is that right?
Russ?
Maybe Russ?
Yeah, so on the headlights, we don't have any that meet the highest standard of being good, rated, and standard on the vehicle. So this is one of the things that is still frustrating for people who may be looking for a top-rated vehicle. They need to get the vehicle equipped with the headlights that earn a good rating, and in some cases they may come as another add-on option, or they may be part of a more expensive options package. And we're trying with our top safety pick ratings to encourage the manufacturers to push them to make the good rated headlights standard across the board. It's also could be a little bit more difficult with the pickups too, in that the headlights are mounted higher on the vehicle than they would be on a regular sedan. And so the manufacturers are going to have to pay special attention to glare because headlights in our tests earn demerits of glare for oncoming drivers.
Yeah, I have an example here. Just looking, for example, at Ram 1500, which is, like you said, Russ, one of the highest rated full-size trucks that you recently tested. It gets a good headlight rating only in the Longhorn and limited trims. This is according to the data I have. And these are the top trims on the Ram truck. And these lights are pretty advanced. They have adaptive curve assist, so they actually change the direction of the headlight beam when you're turning at high speeds and low speeds. So pretty advanced, and a lot of other manufacturers are doing the same thing, but you cannot get that headlight, on your work truck, basically, that you get from the dealership.
Right.
The other thing that we haven't had yet, and this is not something that's on trucks, but since we're talking about headlights, we might as well talk about it because it will eventually come to trucks. And that is, a lot of the European manufacturers are coming out with laser headlights, right, that are adaptive so that they can actually change the pattern as other cars come at them, right? So imagine you're talking about lights that actually steer right with the vehicle, but the laser lights actually can dim part of the light so that when the vehicle is coming at you, you're not, sending glare at them. But then when it passes you, then it illuminates a larger area. But yet those lights aren't here yet. I know the Europeans find it really frustrating that they have those lights, but our federal government has not certified those yet.
That's right. And we have had manufacturers manufacturers demonstrate those lights for us, and they're really, really interesting and could represent a significant advance in safer headlights. And you're right, there is this stumbling block where the federal government has not allowed those European headlights into the U.S. yet. But I think it's likely that sometime in the next few years they will amend that and begin to allow them into the U.S. Or the manufacturers may change the design slightly in order to meet U.S. regulations. But they could be a significant advance.
But can I ask you another question specifically to trucks? One of the things that I think is underrated and really not spotlit in trucks is cab intrusion from loads in the back, right? So in a crash test, a car most likely will not have anything in the bed that can then come flying into the cab. But in pickup trucks, that's a very common issue. You can have all kinds of different loads, and then you're talking about not just hitting something, but then having something from behind come into the cab and potentially, either hurt you or damage the vehicle. Have you guys given any thought to actually doing testing where you have a load in the back of the pickup and have a crash test so you can see how strong that wall is behind the pickup to keep that load from actually entering into the cab?
Yeah, we've talked about that, and we haven't done any testing in that area, but that is something that could pose additional risks in crashes involving pickups. But it's not an area we've been able to explore yet.
Okay, what's coming next? You've just done headlights. Where's the next frontier for you guys?
Well, we're looking at a couple of different things. One of the things, as we were talking earlier about how the vehicle mix on the road has changed, as the market has changed with more pickups and more SUVs on the road, the risks have probably changed in collisions. And one area we're looking at is side impact protection. We have a side impact test that was designed in the early 2000s that we think needs to be updated. It needs to be updated to reflect the newer pickup and SUV designs that may pose bigger risks for people in passenger cars in crashes. And as states have been raising speed limits, we've been looking at raising the speed limit of that side impact test. So we're planning to introduce a new side impact test probably early next year that takes into account those changes. We're also looking at rear seat protection. One of the things that people don't realize, people sitting in the front seat, is that not only do you have airbags and crush zones and advanced design of the vehicle in the front, you also have a very sophisticated seatbelt that is designed to work with the airbags in the front to help lower the forces in a crash. And those seatbelts have very specific features that allow the shoulder belt, for example, to pay out a little bit in the initial impact to lower forces on your chest, and then pull back to keep you in place moving into the airbag as the crash continues. People in the rear seat typically don't have those kinds of features. And so we're seeing more risk of injury to people in the back seat in crashes when they're properly belted than we did before. I guess what I should say is that even though as we've made these advancements in the front seat has become much safer than it used to be, but those same improvements haven't occurred in the back seat. So what we're going to be doing is doing a series of crash tests where we look at that seatbelt performance with an eye toward encouraging the manufacturers to put those advanced safety features in the safety belts in the back seat like they have in the front.
I think, from my experience, I would actually take a step back. I go on a lot. I used to go on. I don't go anymore because we're all locked down. But on a lot of programs where I get picked up at the airport and then taken to the hotel, And I can't tell you how often I would see fellow journalists not buckle themselves in the back seat. There's something about that back seat where people somehow just assume that you're safer and you don't need to buckle yourself in. So yeah, congratulations. But hey, I would just be like, hey, put the seatbelt on in the back too.
Well, we did a study.
I was going to say it must be a school bus mentality, right? You're in the back of the school bus.
Or I guess a limousine mentality or something, where people remember going to prom or whatever and not wearing a seatbelt in the back. But you're right, that's a big issue, and especially now with before the pandemic, Uber and Lyft being so popular and people not wearing their seatbelts in the back seat. And we did a crash test, which is on our YouTube channel, showing what happens when somebody is not belted in the back seat. And what happens is you're not only putting yourself at risk, but your body becomes a missile in the crash and comes forward and can seriously injure the people who are sitting in the front, who may be doing the right thing in terms of having their seatbelt on.
How is autonomy changing, what you're doing? Obviously, the forefront of that probably is either GM with their Super Cruise, or of course Tesla with their full self-driving, which is not full self-driving. It's a good name, but it's not full self-driving, at least not yet. How is that changing kind of your world?
Well, we're doing a lot of research in that area, looking at what types of things need to happen to make sure that the fully autonomous vehicles of the future are safe. And also, we're really focused on the partially automated systems that are on vehicles today, and encouraging those to proliferate when they're performing well, but also monitoring how they are working and how drivers are interacting with them, because getting drivers to be comfortable with those semi-automated systems, and also ensuring that that drivers operate them safely, is going to be important to ensure that people have confidence when we get to fully autonomous vehicles. So we're looking at that a lot. It's not going to eliminate crash tests, because having fully autonomous vehicles running around on the road for consumers to buy is still a very long way down the road, and we're still going to have a lot of crashes between now and then.
Yeah, and as much as I think autonomy is much overhyped, the actual technical ability to do it is much more daunting than I think most people understand. I think it's a very difficult science project. And I'll give you one example of it where it didn't work for me. About a year ago, we bought a Tesla Model 3 just to test. And I was driving it home down one of the local highways, and it was a very sunny day, and there was an overpass, and there was a Subaru behind me. And there was a dip, the car hit the overpass, and there was a shadow across it, and then it went to full emergency braking on its own without me doing anything. Luckily, Subaru didn't ram into the back of me because I floored it. But if I had been sitting there and watching a movie and not paying attention, let's say, it would have been a very tragic. So it works both ways. I think when a plane crashes, most of the time it's human error. So logically, when cars crash, it's usually human error, or often human error. But oftentimes, with the kind of the beginning of autonomy that we're at right now, the start of it also creates issues as opposed to solving problems.
Yeah, there are some of these features, as you mentioned, where we could be creating new problems with people disengaging from the driving task, and it's disheartening for us and worrying for us when people refer to some of these systems as self-driving, when we know they are not fully self-driving, and they require a driver's full attention to oversee what the vehicle is doing. And if drivers are becoming disengaged from that, we could be creating new hazards where we're trying to overcome some of those hazards with technology.
Now, have you guys tested any of the heavy-duty trucks? Have you gone down that far, or no?
No, we haven't tested any of the heavy-duty trucks, and we don't, for a couple of reasons. One is that we have limited resources, we want to focus on the more family-oriented vehicles. And also, some of the heaviest vehicles start with a very high level of safety because of their bulk. So we haven't tested the heavy-duty trucks, and we typically don't test the heaviest SUVs.
That's interesting. Have you done, we talked about rollovers a little bit, right? Truck modifications, suspension lifts. Do you do, or are you planning to do any rollover type scenarios or testing?
Yeah, the only thing that touches that is our roof strength test. But in that test, the vehicle is upright, and we're measuring how strong the roof is and how well it would hold up if there was a rollover. We don't do an actual physical rollover because those tests are hard to repeat and they're hard to control when they're happening. So we haven't done an actual physical roll.
But the government, doesn't the federal NHTSA, they do rollover testing, is that correct?
I think they do a stability test where they're measuring how stable the vehicle is in a series of maneuvers. I don't know about the rollover test itself.
Yeah, and I find the roof strength test and the way you present the numbers is actually pretty quite telling, because you're actually taking the weight of the vehicle itself for the roof test. For example, I'm looking at the data here for an F-150 you tested.
Right.
The weight of the vehicle was about 4,700 pounds. And then the roof strength, when you're pushing on the A-pillar basically, and the windshield area with this giant press, the Ford actually did really great. It was able to withstand up to almost 6 times its curb weight. So it withstood about 27,215 pounds, and it got a good rating. I think that's really good to see.
Yeah, and I think the automakers were not very happy with that test when we first came out with it. I think that their focus was on the ejections and the fact that so many people die in rollovers when they're not wearing their seatbelts. But we were able to show in the data that actually a lot of the serious injuries and deaths and rollovers were not occurring just because of ejection. They were occurring because of the collapse of the occupant compartment. And this is a test that has addressed that aspect of it. And it means that if you are buckled up and your vehicle rolls, it's a bad crash, but if your roof holds up, then you have a better chance of surviving the rollover if you're belted.
So let me follow up on that. We used to go to a lot of press launches where the vehicle would be presented in white, right? Which is basically just the vehicle without any stuff inside of it, right? The chassis. And then the automaker would eventually paint the different types of steel that they were using in the different parts of the vehicle. So, the red was very strong. And the point was, we made the vehicle, it would always say this, we made the vehicle lighter, but at the same time, we've used higher quality steel, more structurally sound steel, better adhesives. So are you seeing that in your testing? Are they telling us the truth? Because we have no way to actually measure that. We just have to take their word at it.
Yeah, they really are. I mean, we don't get into a prescription about what types of steel you should use in your vehicle or anything like that. We conduct the tests, and then the manufacturers figure out how to meet the tests. But they have been doing that using these very high strength but lighter steels, strengthening that occupant compartment, the roof structure. Early in the 2000s when we started the side impact test, that was a big area that the automakers complained about, which is the B pillar, the pillar between the doors, was a key area that they needed to beef up. And some of them thought it wasn't really possible, that our test was going to be too severe to enable them to overcome the impact at the speed we were doing. but their engineers went to work and figured it out very quickly. And now vehicles do very well at resisting intrusion into the side of the vehicle. And of course, now we have standard side airbags that give protection for the head as well.
So I guess my last question, and maybe Andre, you have the last one as well, is, the number is something like, what, 30,000 people die in car crashes every year in America. And that number has actually been holding pretty steady now for a while. Why do you think that is? Why are we still at 30,000 and not at 20,000 or 15,000?
Well, the death rate where you measure per mile traveled has come down substantially over the years. It has also leveled out a little bit too in the last few years. We could be a lot lower. One of the things is that you can improve the vehicle, and I mean the auto industry and safety groups have made a lot of progress in the last 25 or 30 years to make the vehicle safer. But we still have the issue of what drivers do behind the wheel. When people speed, when they drink and drive, when they don't wear their seatbelts, all of those things can't be overcome with a good rated vehicle in a crash test. And so we need to make a lot more progress in those other areas in order to bring the numbers down.
That's very interesting. And probably the number of vehicles is increasing. It's not decreasing, right?
Right. Yeah, we've got a lot more vehicles on the road, and so the actual risk of being killed in a crash is a lot lower than it used to be. But we still have these driver behavior issues, which are the toughest things to deal with.
Yeah, those guys in the back seat not belting up. Come on.
Right.
Well,
right.
Russ, thank you very much. Andre, are there any other questions that you wanted to ask that we didn't hit?
No, I think it was a really good show. I learned a lot. I learn a lot every time. So, Russ, please, you guys at IIHS, continue to do what you're doing, and also publish that data, because I think that's important.
Yeah, and do more videos. We love those videos. They're, because
and
they're very informative.
And if you guys want to make a road trip sometime, we'd be happy to host you at the Andre for the first time at the Vehicle Research Center. And those of you who've been there before, you're welcome to come anytime.
So what happens when you crash them? Where, I know you buy it from the dealer, but let's say you crash that F-150. Where does it go after that? Do you just go to the scrapyard?
Yeah, we have an agreement with a local salvage yard, and the vehicles go to salvage, and the things that can be recycled are recycled, and we get a little bit of money back from having purchased the vehicle through the salvage process.
Yeah, because as a guy who loves cars and trucks, it's always painful to see these brand new vehicles.
Right. Yeah.
Get smashed to bits.
Yeah.
All right. Well, thank you guys for joining us. Thank you, Russ, for taking the time and letting us know about what you guys are up to. And yeah, once we're traveling more often, we'd love to come down and visit you and actually, see the sausage being made, so to speak.
Yeah.
Literally. And yeah, thanks for filling us in on what's happening with truck safety. I really appreciate it.
Great. Okay. Well, thanks very much, guys. Thanks for having me on again.
Thank you.